Okay, so for 9.2, we're going to look at some more identities, and these are going to be called the sum and difference identities. Okay, so what these are going to be, these are going to be just more identities that we can use with our trig functions. It's going to be taking something that's of the form of two angles added together. That's a sum formula, and then we have a difference where they're subtracted. Okay? Now, the derivation of these guys, the proofs, is in the book. They are long. They're a little bit complicated to follow. I'm not going to expect you to remember it. So if you want to see that, that's in the book. But I'm just going to give it to you here. So for cosine of two angles added together, we can write that as cosine of the first angle, cosine of the second angle, minus sine of the first angle times sine of the second angle. Then for subtraction, we can do cosine of the first angle times cosine of the second angle, and then we have plus sine of the first angle times sine of the second angle. Okay? So why are these useful? Well, if you look at your unit circle, we only have what we call the nice angles on our unit circle. If we have an angle that's not on there, but we could write that angle as a sum of two angles that are on there, then we can use that. So let's do some examples. Let's try to find cosine of 75 degrees. So if we think about that, so 75 degrees is not on our unit circle, but 30 degrees and 45 degrees are, and 30 plus 45 is 75. So we could write that as cosine of 30 times cosine of 45 minus sine of 30 times sine of 45 degrees. And then just pull those values straight from the unit circle. So cosine of 30 degrees is the square root of 3 over 2. Cosine of 45 degrees is the square root of 2 over 2. Sine of 30 degrees is 1/2. And sine of 45 degrees is square root of 2 over 2. Now, if we multiply these together, the square root of 3 times the square root of 2 is the square root of 3 times 2, or the square root of 6. So this is the square root of 6 over 4. And over here we have the square root of 2 over 4, or we could write it as the square root of 6 minus the square root of 2 all over 4. Okay, now what about the difference formula? So I want to do the difference formula. So coming up with a sum is relatively easy. You could just think about what you could add together. The difference is a little bit harder, but you can do it with difference. And I'm also going to do this with radians. Radians are a little bit harder because it's kind of hard to think about, what like fractions, especially with pi in it, add up to do something. So let me show you an example. Let's say we have cosine of pi over 12. Now, we can actually write pi over 12 as pi over 3 minus pi over 4. Let me explain why. If you did pi over 3 minus pi over 4, you'd have to have a common denominator because it's fractions. So the common denominator would be 12. So you'd have to multiply this by 4 and this by 4, and this by 3 and this by 3, which gives you 4 pi over 12 minus 3 pi over 12. And then if you just subtract the top part, you end up with pi over 12. So up here, we could write this as cosine of pi over 3 minus pi over 4. Again, that takes a little bit of practice, what I just did, but it's doable. Okay, so if we do the difference, which is the second little formula there, we can do cosine of pi over 3, cosine of pi over 4, plus sine of pi over 3, sine of pi over 4. Okay, which if, again, we can go back to the unit circle. Let's see, cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Plus sine of pi over 3 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. Which gives you the square root of 2 over 4, and then the square root of 6 over 2, which we could write it as the square root of 2 plus the square root of 6 all over 2. Okay, now that's going to be the sum and difference formula for cosine. Let's look at the sum and difference formula for sine. So, the sum formula for sine is going to be sine of the first angle cosine of the second angle plus cosine of the first angle sine of the second angle. The difference formula is going to be sine of the first angle cosine of the second angle minus cosine of the first angle sine of the second angle. Okay, so let's do an example. Let's say we want to do sine of 15 degrees. Okay, so the simplest one you could probably come up with is 45 degrees minus 30 degrees. So that would be sine of 45 cosine of 30. This is the difference formula. Minus cosine of 45 sine of 30, which is square root of 2 over 2 times cosine of 30. Let me go back to my unit circle here. I got it on another screen. Is square root of 2 over 2. Oh, sorry, square root of 3 over 2. Minus square root of 2 over 2, and then sine of 30 degrees is 1/2. Square root of 6 over 4 minus the square root of 2 over 4, or square root of 6 minus the square root of 2 all over 4. How about this one? Let me come up with another good example here. How about sine of, let's do trying to come up with something that's not on the unit circle. Let me see here. Let's do 195 degrees. Okay. So we could pick a couple different things, but I'm going to do it as a sum formula. If you think about that, we can do it as 150 degrees plus 45 degrees. 150 degrees is one of our nice angles on the unit circle. So we could write this using the sum formula. let me scroll back up to it. It's going to be sine of 150 times cosine of 45 minus cosine of 150 times sine of 45. Okay, so if you look at your unit circle, sine of 150 degrees is 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 150 degrees is a negative square root of 3 over 2. And sine is square root of 2 over 2. So we get square root of 2 over 4. And then we get a negative or plus square root of 6 over 2. I know we're getting some of the same answers over and over again, but I'm just using it as an example. Okay? So there's our sum and difference formulas for sine. And we also have a sum and difference formula for tangent. Again, the derivation of this formula is in the book. You can go look at it if you want to. But tan of alpha plus beta is going to be tan of alpha plus tan of beta over 1 minus tan alpha tan beta. And then if we want to do the difference, alpha minus beta, it's going to be tan alpha minus tan beta over 1 plus tan alpha tan beta. Okay, so let's do an example. Let's see here. I'm trying to come up with a good example here. Let's just do an example. Let's do pi over 6 plus pi over 4. Just give the angles there. So let's see here. If we plug this into our formula, it's going to be tan of pi over 6 plus tan of pi over 4 over 1 minus tan of pi over 6 times tan of pi over 4. Okay, if we look at our unit circle, tan of pi over 6 is 1 over the square root of 3. Tan of pi over 4 is 1. Then we have, sorry, I'm trying to scroll back and forth on my stuff here. We have 1 minus tan of pi over 6. We said it was 1 over the square root of 3. And then times 1. Which if we simplify, we have 1 over the square root of 3 plus 1 over 1 minus 1 over the square root of 3. Okay, there's some simplifying you could do there, but that's good enough for me. Let's do tan of, I don't know, let's do one with degrees. Let's do let's do 135 degrees minus 30 degrees. Okay. So, I'm going to get it where we can see it. That's going to be tan of 135 degrees. This is using the difference formula. Minus tan of 30. over 1 plus tan of 135 degrees tan of 30 degrees. Okay, so tan of 135 degrees is going to be -1. Tan of 30 degrees, I just did, didn't I? Power 6. Yeah, it's the same thing. Is 1 over the square root of 3. Then we have 1 plus a -1 times 1 over the square root of 3. So we have -1 minus 1 over the square root of 3, and we have 1 minus 1 over the square root of 3. Okay. Now that's just the application of those trig identities. We can also prove other identities like we did in the last section. So let's see here. Let me scroll down and find some examples. Yeah. So let's look at this. Let's prove this identity. Okay, these are not the ones that we would consider fun, but they're necessary. Okay, let's prove this identity. So if you remember, when we do this, we take one side and try to make it look like the other side. Now, we usually take the more complicated side to make it look like the simpler side. So let's look at the left-hand side. Let's see if we can get the left-hand side to look like the right-hand side. So on top, we obviously have a difference formula for sine. So let's convert it to its difference form, which is sine of alpha cosine of beta minus cosine of alpha sine of beta. Let's double check. Let me look at that. Make sure I got the signs right. This is for sine. Yeah, I got it right. Okay, and that is all over cosine of alpha cosine of beta. Now I'm going to split this guy up. Anytime we have a single expression on bottom, we can put it over each piece individually. So I'm taking each piece on top and putting it over the cosine alpha cosine beta. So let's see what cancels. Those guys cancel and those guys cancel. We're left with sine of alpha over cosine of alpha, which sine over cosine of a certain angle is just tan. Same thing on the other side. We have sine beta over cosine beta. Sine over cosine is tan. And this is exactly what we were trying to get it to look like. So that's the proof. Okay? So I'm just going to show you, you can apply those same identities to those proofs like we were doing in the last section. All right, so we'll stop there.